means of continuation. Okay, for alkane, CnH2n plus 2. So we have, when n equals to 1, we have C into bracket 1, H2 into bracket 1 plus 2. So we have C1 or H4. So by explanation, we have CH4. So this is called methane. You can continue to change the value. When n equals to 2, you have C2 H2 into bracket 2 plus 2. So we have C2 H 2 times 2 4 plus 2 6, and this is what now this and all this we can continue like this until we get to decay. So we have methane, but the truth remains that for alkene, it does not have a single bond. It does not have the first member, which is a methane. So because it has a double bond, and the formula is CnH2n. Okay, so when you make n, so you start with 2 because you cannot have 1. A double bond has to go with 2 carbons, this and this. So if it has to be a 2 carbon, then it is an ethene, not a met. So methane and methane does not exist. So for alkyne, you have C. It also has to be a double bond. Then you have CnH2n minus 2. So when you go over it, you have C. When n equals to 2, you have C into 2, H2 into 2 minus 2. Okay. So what do you have? C2, H2. Okay. And by this, you cannot have it. So you have C triple bond theory. So I'd like you to know that in drawing the structure, each carbon bond is attached to 4 hydrogen atoms. And so what do you have? So to form a bond here, for example, 1, 2, 3. So you have H, 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 H. So 1, 2, 3, 4. This carbon atom has 4 hydrogen atoms. 1, 2, 3, 4. It has 4 hydrogen atoms. Here we will have 1, 2, 3, 4. Here we also put an 8. So that's how we form it. 1, 2, 3, 4. 1, 2, 3, 4. That's how you go by it. And we shall continue from this in the next class. So we will now continue to how we are going to and why do we have all of this. And as a matter of fact, we will learn continuously from there. Okay, now I'd like to show you this quickly. Organic chemistry give reasons why compounds are many sources of organic compound. Okay, so we have it like that, and the definition: organic chemistry is the branch of chemistry that deals with the study of organic compounds. The word organic was originally used to describe substances from all living sources, plants and animals. Today, many organic compounds are synthesized in the laboratory from inorganic compounds. All organic compounds, whether natural, synthetic, contain the element carbon. Thus, organic chemistry is defined as the chemistry of carbon compounds. And then, carbon compounds are studied in organic chemistry as though carbon compounds are studied in organic chemistry as those that possess carbon bonds in their molecule. Most of them are hydrocarbons. We have alkene, alkene, alkynes, and the arenes. Arenes are the aromatic. Why organic compounds are many? There are several reasons why we have many organic compounds. The first is ability to catenate. Catenation is the property of forming bonds with atoms of the same elements. Okay, so that is what we call catenation. A variety of and diversity of organic compound are formed because of its ability to catenate. So we have straight chain, we have branch chain. This is the cyclic form, okay? And then another reason why we have so many carbon compounds are because they are tetravalent, because of tetravalent nature of carbon. Carbon has only 2 unpaired electrons in the ground state. Ground state is the state before it assumes, before it begins the reaction. If the reaction starts and there is oxidation or reduction, you call it excited state. However, during chemical combination, the carbon compound atoms requires enough energy to promote one of its 2s electrons to 2pz, thereby leaving 4 unpaired electrons for bonding. The ability of carbon to form 4 bonds allows atoms of other elements to join carbon skeleton. Okay, so look at this bond angle. This is a methane, for example. This is 1s, 2s, 2px, 2py, 2pz. Now, the first electron spin in directly first, singly first, then they begin to pair. These ones cannot be paired, and this is the ground state. This is how it is in the ground state. But at the excited state, one electron has to get here too, and it continues all that way. Number 3 reason why carbon compounds can form so many is the ability of carbon compounds to form multiple bonds. Carbon has the tendency of forming multiple bonds, double or triple, with its own atoms or with atoms of other elements such as oxygen and nitrogen. Carbon has 2 bonds to oxygen. It has 2 bonds to oxygen. Carbon has 2 bonds to oxygen. Okay. And it has 3 bonds to nitrogen. Oxygen and sulfur. Carbon has 2 bonds to them. It has 3 bonds to nitrogen. So double bond between 2 carbon atoms. Okay. This is a triple bond here. 1, 2, 3. So 3 bonds to nitrogen. Triple bond between a carbon-carbon atom. Okay, now triple bonds of 2 carbon atoms. This is a 2 carbon atom. Now, ability to form bonds with other elements. Because it has ability to catenate, it can form bonds with several other elements. Now, we will be fast about it. Sources of organic compound. The first source is plant and animals. It's also sourced from coal, petroleum oil, and natural gas. Compounds such as methane, propane, and butane are constituents of natural gas. Okay, so petroleum oil we get from lubricating oil, Vaseline, petrol, kerosene, and all those. So they are also sources of organic compounds. General characteristics of organic compounds. We have physical states, linkage, melting and boiling points, and thermal stability. All these are physical properties, most especially melting and boiling points. Okay, melting and boiling point is the issue of the first physical state, general characteristic physical state. Organic compounds with weak intermolecular forces exist at room temperature as gases, volatile liquids, or low melting point solids. Linkage. Now, when we talk of the melting and boiling point, their low melting and boiling point is due to the presence of weak intermolecular forces such as van der Waals forces and hydrogen bonds. Thermal stability. Organic compound are less stable to heat compared with other inorganic compounds. Now, classification of organic compound. Okay. Organic compounds are classified based on the similarity of their structures. We have aliphatic and aromatic, as I have shown you in the first video. We will stop for now, and in the next class we shall continue from here.